Joe from Gray Bench Electronics here. Today we're checking out a vintage amp from the 1950s. This is an English Electronics Tonemaster. So this amp was made by Valco. Valco made amps for a bunch of different companies in the 50s, one of which being English Electronics, which was a company out of Michigan, ironically. But today we're just going to open it up, make sure it's safe to operate, replace any parts that need replacing, check the bias on the output tubes, make sure that's good to go, and check out the speaker, make sure that's in good condition as well. And then we'll put it all back together and do a listening test. All right, so just want to get a good look at the amplifier. We can see we got some wear to the Tolex on the edges, which after 50 some years of use, you would expect. Coming around the back here, same thing on the edges, a little bit of damage to the wood as well. It does appear to be a hardwood cabinet, probably of pine. I can tell just looking at the way the Tolex wore here, it is finger jointed. The Tolex otherwise, except for a little bit of wear, is in pretty good condition. I like this kind of speckled tan with the black. It does have piping around the two segments here, which is nice. High and low volume, and then a simple tone control. Fuse, which has the correct value in it, which is good. Always good to check that when you're buying an amp. Make sure it's got the correct rated value. If you see a higher value in there, good chance that there's something wrong with the amp, that they were trying to just get away with a quick one on you. Simple on-off switch, no standby switch. We are tube rectified, indicator lamp, 3 inputs. The output transformer is disconnected for some reason. We'll investigate that. The tube complement is two 6v6s. We have a 6SC7, most likely the phase inverter, and then a 6SQ7, and then 5Y3 is the rectifier. The speaker in there is a Rolla speaker. Yeah, so hopefully you can see there that the output transformer is mounted to the speaker as opposed to the chassis where you would expect to see it on a modern amp. Not a big difference, just running the primary of the output transformer as wires up into the chassis, and then the secondary just connects to the speaker right down there. The amplifier does now have a polarized power cord or 3-prong power cord, which means an amp tech has been in here at some point to at least replace the power cord. So we'll see what other work has been done to the amp, and like I said, check and make sure it's all good to go. All right, so to take apart this amplifier, this whole front panel comes off. Luckily, like I said, the output transformer primary is disconnected, and so that you'd have to do something with to take apart the amp fully and have good access to the chassis. So that's decided already, so we're just gonna pull the whole panel off. It's connected here by 4 wood screws. I'm gonna undo those. I'm holding the panel into the cabinet so it doesn't come flying out. Just putting light pressure. There should be a notch in there, so. On the speaker here, our code is 285713. 285 is the EIA code for Rolla. 713 indicates 1957, 13th week. It is a 10-inch speaker. Looks to be in good condition, but we'll pull the speaker off and have a better look at the cone on the other side. There's the inside of the amplifier. Okay, so in this amp, there appears to be studs that are hammered in on the front panel that have threaded pieces that stick forward, and then the chassis is attached to that, and it's got some diagonal braces mounted as well. So I'm going to unscrew that from the chassis and pull the whole amp out, and then we'll have a look at that. All right, so here's the chassis of this English Electronics Tonemaster. Definitely some work been done in here. So we got our 3 inputs. They all have 47K grid resistors, so they're all equivalent. Switched grounding jacks. First stage here is that 6SQ7, which is a single triode with some diodes. The diodes are just connected to ground. We do have this newer cathode bypass cap. My guess is this didn't have one at all. This was just an attempt to get more gain out of the stage. This coupling cap appears to have been replaced. It's coming off to the volume control, so that's going to be the coupling off the first stage. It also looks like maybe a a filter cap up here in the connected to the plates of the first stage. What this doesn't appear to have is any type of like higher capacitance filtering off the last node here. I'm not sure if that's original or not. This is just a kind of small cap here to ground. And then it goes into the 6SQ7, which is a dual triode. So over on this side, we have our tone control. That's just a cap going off the ground with a variable resistor here. The bypass caps going into the output tubes have been replaced. That's the film caps down there. There's this large capacitor here, filter capacitor. It's definitely not original. It's also a pretty high value. 80 microfarads is a lot for a tube rectified amp. It appears to be just in parallel with the first can capacitor stage here. This is a Mallory can capacitor. It's 3 section 10 microfarads each. And this cap here is just in parallel off one of the sections here. My guess is that's the first stage after the rectifier. And that's a lot of capacitance for a tube rectifier. A 5x3, the max reservoir capacitance I think is like 33 microfarad. This is going to be 10 plus 80 is 90 microfarad. So that's a lot. We will probably replace this with a 22 microfarad. That would be 22 plus 10 is 32. So that would be right at the max there. Big old dropping resistor here in the power supply. It's a 1K ohm, looks like 5 or 10 watt. And then another of the same power rating down here, which is going to be the cathode resistor for the two 6v6 output tubes. Everything else looks pretty standard. Indicator lamp coming off the 6.3 volt heater supply. I did notice that the center tap for the filaments is tied to the cathode of the power tubes, which is something you can do in order to try and reduce hum. It's just like a DC elevated point for the heater supply. All right, so I think I'm just gonna draw up the schematic now and we'll have a look at that. All right, so here's the schematic I made for this amplifier. We have our 3 inputs here, the 3 47K grid resistors. First triode here, the 6SQ7. Everything's pretty standard here. I'm not sure if this 22K or 22 microfarad cap is stock to the amp. 47P little cap here to ground, just probably rolling off some real high-end stuff. Could also be for filtering out interference. I'm not sure on the value of these potentiometers. I'm guessing 500K. Might be 1 meg. Standard tone cap, sending high frequency to ground and putting resistance in there to about just how much signal goes to ground through that cap. Standard volume control here. And then it comes out here to the 6SC7, which is that dual triode, and it's set up in this is called a paraphase phase inverter. Signal comes in to the first triode here, comes out inverse phase, 180 degrees out of phase from this plate into the first output tube here, taps off of there with a little voltage divider here. A certain amount of signal comes back here to the second triode here. It's still 180 degrees out of phase from the original signal coming in. Then we go back another 180 degrees out of phase from this plate, which is 0 or 360 degrees phase to the original signal, and that goes to the other tube. So you end up with your out of phase signals going to your 2 output tubes. 200 ohm cathode resistor. We're going to check and make sure that's giving us appropriate amount of dissipation in the tubes. The screens do not have any type of individual screen resistors, so we might consider putting those in. Standard output transformer configuration. Over here on the power section, this isn't my preferred setup for the primary of the power transformer. In my opinion, it should be hot to the fuse just like this is, but then fuse the switch and then that into the transformer, and the neutral should be just hardwired into the other side of the primary. Secondary here, pretty standard. High tension winding into the plates of the 5Y3. 5 volt filament winding for the 5Y3 is there. 6.3 volt. Obviously it's going to go to the heaters of the tubes and to the indicator lamp, but the center tap here, rather than being tied directly to ground, it is tied to this point here, the cathodes of the output tubes, which will DC elevate that winding, which can eliminate hum. So pretty simple amp. Here is that 80 microfarad filter cap. Like we can see, it's 2 caps in parallel, so you add their capacitance together, so that's a total of theoretically 90 microfarad. That is too much capacitance for a 5Y3 rectifier, and rush current is going to sooner rather than later cause arcing in the tube. So this 80 microfarad cap, we are going to reduce this to 22 microfarad and see how we get on. But first, actually, we're going to disconnect wires from this can capacitor and measure it and see what it looks like. All right, so I have the CAN capacitor now disconnected out of circuit. By the way, if you ever are doing something like this where you know you're going to be wanting to reconnect things in the same way they were connected before, just use your phone and take a picture of it. So we got the cap disconnected. I've got just a standard multimeter here set to the capacitance tester. I'm going to connect up to each of the sections and see where we're at. All right, so 11 microfarad on that section. This is the section that had the 80 microfarad cap connected. 11.1, 11.4. So all the sections are well within spec. They're, you know, around 10% above, but that's totally normal for electrolytic caps. So as far as capacitance, that CAN capacitor seems okay. That's not proof that the capacitor is in good condition. There could be a high ESR condition, which is equivalent series resistance, which could effectively cause it could cause the capacitor to heat up and deteriorate further. It could hamper the filtering properties of the capacitor, so we could get hum. It really depends on what the tech who put this in was trying to do. I'm going to follow my gut on this one. I'm going to replace this 80 microfarad capacitor for a 22 microfarad at 450 volts capacitor, which is within the rating for the 5Y3 rectifier, but also has that higher filtering on the reservoir node, or the first capacitor stage after the rectifier. So we're going to do that now, and then I think we'll be able to fire up or power up the amp, and we'll check some voltages, check our bias on the output tubes, and see where we're at from there. All right, I got the amp hooked back up here, ready to start applying power. Took out the 80 microfarad cap, put in this 22 microfarad at same voltage rating, 450 volts. I did bring it up on a current limiter at first, just to make sure I didn't inadvertently create a short anywhere. I have my multimeter probe attached to the plate of the 6V6 there. So ready to give it some power here. And we're going to measure the current flowing through that cathode resistor, which will tell us about the bias conditions. Just waiting for the voltage to settle off here. Looks like we're pretty stable now. We're drawing about 700 milliamps, or 0.7 of an amp. And we're at 360 volts on the plate. Let's check the cathode. Cathode has 20.7 volts. So if I plug that into the tube calculator, I use a Rob Robinette's tube calculator, that's 360. 360 on the plates. Plate to cathode then would be about 339. And we'll calculate. So that gives us 118% plate dissipation on the tube. So running the tube's about 20% harder than they should be. And that means we need to adjust the cathode resistance for the output tubes. This is a normal procedure for this kind of amp, because back in the day they didn't have 120 volts coming from the wall. They had 110, 115, 117 volts. At those voltages, we definitely would have been much closer to 100% plate dissipation. But now that we have 120 volts plus coming from the wall, we need to adjust that cathode resistor so that we're not running the output tubes in excess of 100% plate dissipation. So we're gonna change that next. All right, so I got a new cathode resistor in there. I went from 200 ohm cathode resistor, that's what was in the amp stock. We now have a 300 ohm resistor in there. So let's fire it up. It's always a bit of a balancing act, trying to choose a new cathode resistance. You can get these devices called decade boxes, which just let you switch through a bunch of different resistances. That's a very useful tool. One thing you'll notice here is that the B+ voltage can actually rise above the rating of the capacitors. That's just how it is. The 5Y3 is a really fast starting rectifier tube. Got 377 volts on the plate. Cathode resistor now, 24.1 volts. So currently we're at 95.7% plate dissipation. And I got 119 volts on the variac. So that's a safe distance for me. If the wall voltage rises as high as 120, 121, we're still not going to push much past 100% plate dissipation, if it does push that at all. So that's fine for me. Some people like to run 6v6 harder than that. To each their own. I stick to what the data sheet says. Another thing I noticed as I was playing with this is, I don't know if you can hear it, but the tubes are quite microphonic. That's one of those things where, number one, I don't have tubes to replace that on hand. And, you know, it could also just be part of the character of the amp. So that's good enough for me, though. I'm going to put the amp back together. You can see the wall voltage rose up to 120 volts. It must have been something turned off in my place here, and the plate voltage went up accordingly. Next up, we're gonna have a look at the speaker and see what condition it's in. It seems to be fine, sounds okay, so let's check it out. All right, so here is the Rolla speaker. As you can see, it's in very good condition. I would say very good to excellent condition. It looks original to me. I'm not that an expert on speakers. I'm definitely not Rolla speakers. The cone is obviously clean and intact. A few Rolla speakers I've seen, this looks correct with the little felt dust cover there. So when I'm checking a speaker, what I'm looking for is I want to hear a nice percussive sound when I tap the cone like so. Should sound sort of like a drum. And then you can put your hands inside the cone and just flex it back and forth. And when you do so, it should be nice and springy. You don't want to push too hard or too far up or down. Just nice, gentle pushes. And you shouldn't hear or feel any type of grittiness. It should be nice and springy and no resistance. This one seems just fine. So now we checked out the speaker, I'm going to put that back together, put the cabinet back into the put the chassis back into the cabinet and bolt it all together, and then we'll throw a mic in front of it and see how it sounds. All right, so amps back together, ready to do a listening test. Going to fire up the amp now, play a little bit. You'll get to hear, I'll go through the controls, and we'll push it into overdrive a little bit so you can hear that. So you can hear some microphonics going on. Those two preamp tubes are pretty microphonic. You can definitely hear that coming through. Also a little bit of 120 hertz hum there. That's 60 plus year old filter caps. It's not going to be ideal, not going to be perfect at filtering out that noise. It's likely the problem that tech was chasing, trying to throw in that 80 microfarad cap into the power supply. However, you can't exceed the capacitance ratings for the rectifier tube in your pursuit of getting rid of that hum. So yeah, let's keep playing. All right, let's push it into overdrive here. to beat up that speaker too hard. I want to show the range of the tone control. So here's all the way bassy. A little more highs. A little higher. A little more. And pretty much max out high there. Tone control sounds pretty good right there in the middle. Yeah, so there's the amplifier. That's what it sounds like as it sits. All right, so I think we're going to wrap up the video there. I hope you enjoyed checking out this old Valco amp from the 1950s, English Electronics Tonemaster. Obviously, the work is not done here. We have still some issues in the power supply with filtering. There's still a little bit of 120 hertz hum in there, as well as the preamp tubes that are microphonic. So I will be revisiting this amp sometime in the future, and we will look at redoing the power supply to alleviate some of those issues, as well as swapping in some preamp tubes for ones that don't ring. I think I'm going to keep this amp for my own collection. I've always wanted an old Valco, and I think this is a fine example. So I hope you enjoyed the video. If you did, I'd appreciate you hitting the like button. And if you want to see more videos like this, feel free to subscribe to the channel and hit the notification bell so you know when I make a new video. I am Joe from Great Bench Electronics. Thank you for watching.